Scalar quantities are quantities that has magnitude as well as size, no direction. Scalar quantities are quantities that has magnitude as well as size, but no direction. But vector quantities are quantities that has both magnitude and direction. It has both magnitude and direction. It tells you where and what to do at every given point in time. A scalar quantity has only magnitude, no direction. It is not specified. There is no rule, there is no direction where to go. But in vector quantities, it has magnitude, it has size, as well as direction. It is specified. And there are rules governing how to solve vector quantities. Vectors quantities. Now, if I have two vectors that are moving in the same direction, now I have to add their resultant. I add. The first thing I do is add their resultant because they are moving in the same direction. But if they are moving in the opposite direction, let's say, and this, and I'm asked to find a resultant, what do? I subtract. I subtract their resultant because they are moving in the opposite direction. But if they are moving at a right angle triangle to each other, what do? 3, I use the Pythagorean theorem, which is a square is equals to b square plus c square if they are moving at a right angle triangle to each other. Now, if the same two vectors, since they are at a right angle triangle to each other, it has to be sustained by an angle, theta. The angle theta becomes tan theta, which is opposite over adjacent, when they are being sustained at an angle, at a right angle triangle to each other. And that 5, if they are moving at an obtuse angle or an acute angle that is slightly above 90 degrees or below 90 degrees, I use the cosine rule, which is r squared is equals to a squared plus b squared plus 2ab cos theta. When they are obtuse or an acute angle, when they are less or above 90 degrees, I use the cosine rule, and it must sustain at an angle. I use the sine rule, which is sine a all over r is equals to sine theta all over a. When they are moving when they are being sustained at an angle, if the two vectors is an obtuse or an acute angle. Hello viewers, welcome once again to Fame Global Academy, and I'm your favorite physics teacher, Fred Mark. And our topic for today is scalar and vector quantities. Scalar and vector quantity. We're going to talk about the concept of scalar and vector quantity. But before we go through that, let's take a look at what we did in our last class. Let's just go through them. If you can still remember, we talked about acceleration, uniform acceleration. When is a body is said to be undergoing a uniform acceleration. We talked about rectilinear acceleration. What is linear acceleration? We also talk about the formula for acceleration, where we said that acceleration is change in velocity with time. And we say A is equals to V minus U all over T. A is equals to V minus U all over T, where A represents acceleration, V is final velocity, U is your initial velocity, where your T is time. Remember, I've said it so many times that symbols are very, very important in physics. And then we went to talk about the 4 equations of motion, which was proved. In our last class, we proved the equations of motion, and which are, we said V is equals to U plus AT, and we said it's equation 1, and we have S is equals to U plus V all over 2, equation 2, and we said S is equals to UT plus half AT squared, equation 3, and I have V is equals to U squared plus 2AS, equation 4. And these are the 4 equations of motions, and then we use these equations to solve problems. And we say that v is representing final velocity, u is initial velocity, and acceleration is a, and t is time. S here represent distance, how far a body travels can be calculated using this formula from our velocity time graph, which we discussed in the other two classes. And then v is equals to u squared plus 2as is also formula to calculate velocity, as the case may be. In an equation, when I'm giving distance and I'm also giving uh, initial velocity and acceleration, I'm asked to calculate the velocity, which is the final velocity v, I should use equation 4. But if I'm giving time and acceleration with our initial velocity, I should use equation 1, not equation 4. Equation 1 is and equation 4, they're almost the same, but if you look at it, there are difference in their symbols. We have S here and we have T here. So when I'm asked to calculate velocity and I'm given distance, I should use equation 4. The same thing happens to equation 2 and equation 3. So we talked about all this in our last class and using these equations to solve problems. And for today, we're talking about scalar and vector quantities. Scalar and vector quantities. What are scalar quantities? Scalar quantities are quantities that has magnitude as well as size, but no direction. Scalar quantities are quantities that has magnitude, has size, but doesn't have direction. But vector quantities are quantities that has both magnitude and direction. It has both magnitude and direction. Now, take for instance, if I ask a student now, leave the classroom and then go, there is a bag of gold outside. There's a bag of gold outside 2 centimeters from the, just 2 centimeters, a bag of gold outside 2 centimeters. The question is vague. The person does not understand, where do I go to? When I come out from the classroom, is it 2 centimeters from the door? Is it from the window? Is it at the end of the step or an end of the pavement? The person is confused. That is a vague question, and the person begins to look for that gold. It might take years because he does not know where is the reference point, where is it starting from. But that is now scalar quantity. It has magnitude, it has size, but there is no direction. But in a situation where you are asked to go and there's a bag of gold, the student should leave the class now from the center, from the board, move 20 centimeters to the west the door, eastward, 40 degrees. It is specific, so the person now knows, okay, when I from the center of the classroom is not a reference point, is the position of where the person is standing, walking towards the door, and then moving 40 degrees north or south. It was specified, there's a direction. So the student going to look for that gold, it becomes very easy. In less than 10-15 minutes, the goal is found because the direction was specified, the magnitude was specified, and that is a vector quantity that has both magnitude and direction. But the vector scalar quantity has magnitude, doesn't have direction. As much as you want to go and carry the bag of gold, it's beautiful. Wow, I am moving 20 centimeters, but where? Is it backward? Is it on top of the roof? Is not specified. But when you are given the degree, the direction, whether is it north or south, whether is it 40 degrees southwest, it is not specified. Looking for the bag of gold is easy because there is a direction and there's also magnitude. That's what it's all about. Scalar quantities are quantities that has magnitude as well as size, but no direction. While vector quantities are quantities that has both of them. It has magnitude and it has direction. Now, if you were asked to vectors, scalar quantities has to do with vectors of one magnitude. Vectors of one magnitude. Let's say, like I said before, move 20 centimeters, no direction, just a magnitude. So calculating their resultants, there is no need for doing that because it's just one quantity or one magnitude. But in terms of vectors, vector has more than one magnitude. Now, let's take for instance, somebody is going, if you have two vectors that are moving in the same direction. Take for instance, vector P is going 40 degrees north, and then vector Q is moving 60 degrees let me just say the force acting on vector P is 40 degrees Newton, and the force acting on vector Q is 60 degrees Newton, and I'm asked to find their resultant. Now, because they are vector quantities and they are two forces, they have two magnitudes, and they are going on the same direction. This arrow showing that they are moving in the same direction. So what do? You add their resultant because they are moving in the same direction. So the resultant R is equals to P plus Q. So we have that's 40 plus 60 is equals to 100 Newton. So their resultant is 100 Newton because they are moving in the same direction. I repeat, to have two vectors that are moving in the same direction, how do you calculate their magnitude, their resultant? You add them because they are moving in the same direction. But in case of scalar quantity, it's only a vector with one magnitude. There is nothing to calculate. That is why we deal with vector quantities the more. But then also example of we have parameters that are scalar vectors quantity. We talked about it in the first two classes when we said speed is an example of a scalar quantity. Speed, scalar. We have speed. There are so many. You have mass. You have temperature. You have work, energy, power, and etc. There are many. So speed, mass, temperature, work, energy, power, and etc. These are some of the examples of a scalar quantity. But in a vector quantity, vector, you have acceleration, you have velocity, you have weight, you have momentum, you have magnetic flux, you have displacement, you have electric field, etc. There are still so many. Examples of vector quantities: we have acceleration, you have velocity, you have weight. Remember, in scalar we have mass. In a vector we have weight. There's a difference between mass and weight. Now, we have acceleration, we have velocity. Speed and velocity are almost alike, but speed is a vector quantity, while velocity is speed is a scalar quantity, while velocity is a vector quantity. We said speed is change in distance, distance traveled in an unspecified direction. It's talking about vector of one quantity. And then velocity is a distance traveled in a specified direction. It's been specified, just like scalar has magnitude, no direction. But vector has magnitude as well as direction. So example, we have acceleration, we have velocity, we have weight, we have momentum, magnetic flux, electric field, displacement, and so on. These are some examples of a vector quantity. And so because the vector quantity can be more than one, when two or more vectors, we can calculate the resultant using using other formulas, but they are under vector quantity. And I give an example here. I said if you have two vectors that are moving in the same direction, what is their resultant? Because they are in the same direction, we have to add their resultant. But what if they are moving in different direction? Okay, for instance, we have the same quantity. We have this as okay, let's draw the diagram. We have 60 Newton, and then we have 40 Newton. This is P and this is Q. Now from the arrow now, arrow shows direction. That is why you are having take for instance, you are invited for a wedding and then you are given a direction from the card behind. The arrow showing that if you go upward, there's a bus stop here. Another one is going upward. So the arrow shows the direction of where the object or the body is moving. Now this one now shows that vector Q is moving in this direction and vector P is moving in the opposite direction. The resultant can be calculated, but it cannot be the same. So P arrow becomes P minus Q, which is 60 minus 40. So R is equals to 20 Newton. 20 Newton, because they are going in the opposite direction. So if you have two vectors that are going in opposite direction, I can calculate the resultant by subtracting them because they are going in the opposite direction. But if they are going in the same direction, I would have to add their resultant. Two vectors in the opposite direction, you subtract their resultant. Two vectors in the same direction, you add their resultant. Now, what if the two vectors are not in the same direction? They are not in opposite direction, but they are right angled to each other. What do I do? Do I have to add? Do I have to subtract? In that case, I use what we call the Pythagorean theorem. Now that leads us back to mathematics. Remember I said before, some time ago, that mathematics and physics, they are intertwined. Somehow they are intertwined. So we use some of our mathematical equation to apply in our physics. And so when you have two vectors, that are going in the right angle triangle to each other, take for instance, okay, remember these are four cardinal points: the north, the south, the east, and the west. And I have two vectors. One is going towards the east at, say, 3 Newton, and the other is going upward at 4 Newton. And I'm asked to find their resultant, R. Yes, the arrow shows that this one now is going upward. It's going towards the north, 4 degrees north, and then this other one is going 3 Newton on the east direction. So what do I do? Do I need to add their resultant? No, because they are not in the same direction. Do I need to support the resultant? No, they are not going in the opposite direction. They are going at a right angle triangle to each other. They are making an angle 90 degrees to each other. So what do? I use the Pythagorean theorem, which says that R squared is equals to A squared plus B squared. R squared is equals to A squared plus B squared. Now, the R squared is equals to A is, let's assume this is A and this is B. So we have 4 squared plus 3 squared. R squared now becomes 4 squared is 16, which is 4 times 4. 3 squared is what? 9. And then R squared becomes 16 plus 9, I think 25. Then remember, I am not asked to find the R square. I'm asked to find the resultant R. So R becomes the square root of 25. R becomes 5 Newton. So if they are going at a right angle triangle to each other, they are going at an angle 90 degrees to each other. One is going upward, another one is going sideways. Either this way, or could be west and south. It could be west and north. It could be east and south. It could also be east and north. But if they are going, let's say one is going to the west, the other is going to the east, and that means they are moving in the opposite direction, I can as well subtract their resultant. But in this case, they are going, one is going east, the other one is going north. They are not at the same direction. They are not in opposite direction. They are at a right angle triangle to each other, and they are making 90 degrees. So what do I need to do to find the resultant? I use the Pythagorean's theorem, which is r squared is equals to a squared plus b squared. We have r squared, a squared is representing 4, b is representing 3. You can use any alphabet. You can use r squared is equals to s squared plus y squared. There's no problem. You can use r squared is equals to p squared plus q squared. Any alphabet is not the issue. Just know what you are doing and then apply it. So r squared is equals to 4 squared plus 3 squared. We have 4 squared, which is 16. I have 3 squared, which is 9. 16 plus 9, 25. R is what I'm looking for, not r squared. So if I want to do r becomes the square root. The square goes to this other side. And square root of 25 is 5, because 5 times 5 is 25. So r becomes 5. So this is now, r is now the resultant, which is 5 Newton. 5 Newton. 5 Newton. But as it's doing that, it's making an angle. It's making an angle. Theta. And the angle theta must also be calculated. Sometimes you can ask to be calculated, what's the angle? But what angle was the resultant? At that stage, we have tan theta is equals to, what is tan? There's a short form of knowing what tan, the sine, and cosine. Then we used to call it then SOHCAHTOA. SOHCAHTOA. So the TOA is the tan, which is opposite over adjacent. SOHCAHTOA. That's supposed to be in mathematics anyway. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Then T representing tan, opposite over adjacent. Opposite over adjacent. So this one is now the opposite. The side facing the angle is the opposite over adjacent. So that's what tan is, which is 4 over 3. Tan theta is equals to 4 over 3, which is around 1.33. And tan, remember theta, because the tan inverse of 1.33. So theta becomes tan inverse of 1.33. So tan inverse of 1.33, it becomes 53. 53.13 degrees. So the angle it makes is about 53 degrees. Remember, the whole of this one is 90 degrees. Here, 90 degrees. So exactly half of it is 45 degrees, but we don't know whether it's exactly 45 or above 45, but it's within the range of 90 degrees. So I'm asked to find the resultants of two vectors, one going to the north and the other one going to the east, and it has 4 Newton and 3 Newton, as the case may be. And the resultant happens to be 5 Newton. And once it happens to be 5 Newton, it must make an angle, theta. And I'm asked to calculate at what angle now will it be. So angle becomes 53.13 degrees. So it's not exactly, so from this answer now, it's not exactly 45 degrees. It's above half of it, which is this range, 53.13. It's approximately 53 degrees. And so it is not 90, it's not 45, it's slightly above 45 degrees. So if you have two vectors of two different quantities in the opposite direction, we use the formula of Pythagorean's theorem, which is r square is equals to a square plus b square, or in mathematics it's c square is equals to a square plus b square. But in physics it can be any, but we are using the same procedure. And so r square, I'm using r square because I am dealing with resultant. So r is equals to a square plus b square, and which is 4 square plus 3 square, which is 16 plus 9, 25, and then the square root of 25 is 5. But what is now the angle? At what angle did they meet? And so we have tan theta, which is 4 over 3. So, which is tan theta, if I divide this, I have 1.33. Then remember, I'm not looking for tan. I'm looking for the angle, which is theta. Theta because tan inverse of, if you're using your calculator, you just go in and punch your 1.33 second function tan. You have 53.13 degrees. 53.13 degrees to get your tan inverse. So if you are a student and you're watching and you don't know how to go to look for your tan inverse, you can use your 4-figure table to do that. But if you can't, and for easier purposes, you can use your calculator. All I need to do is press 1.33 second function tan. I have my tan inverse and I'll have 53.13 degrees. Now, having known that you have two or more vectors in the same direction, what do? I will add their resultant. If I have two vectors of moving in different direction, I will subtract their resultant. And if I have two vectors also moving in the opposite, and then one to the north or the south, making an angle 90 degrees, I will not add, I will not subtract, I will use my Pythagorean's theory, which is what we have just done. But what if the angle is not 90 degrees to each other, is either less than 90 degrees or above 90 degrees? Is above, take for instance, like instead of one being here, east, and then west, so it's making more than 90 degrees to each other, or somewhere here is above 90 degrees, not up to 180, somewhere here, this way. Now, if this is the direction, remember, this is 90 degrees. Now, this one is above 90 degrees, but not up to 120 degrees. So, in mathematics, it could be an obtuse, an acute angle, where it's above 90 degrees, but not up to 180 degrees. How do I now find the resultant? In that case, we use the cosine rule. Yes, mathematics now come again into play. We use the cosine rule. We use the cosine rule and the sine rule. But for this foundation, we won't go into that so deep until we get to when we are doing resolution of vectors, when we have vectors of more than one vectors. And now we're dealing with vectors of 2 magnitude. Well, if you have more than one magnitude, say 3, say 4, say 5 vectors, then all I need to do is to resolve them into a single vector, into 2 vectors, and still go back to my Pythagorean's theory and my tan rule. So let's see an example of if the vector now is not 90 degrees, is not the same direction, and neither is it in the opposite direction. I will use the cosine rule. Now, I said if we have talked about we have 2 vectors in the same direction, I said we will add their resultant. We have 2 vectors in the opposite direction, I said we will subtract their resultant. And if you have 2 vectors moving at a right angle triangle to each other or making an angle 90 degrees to each other, what do? I use the Pythagorean's theory. And what if I have angles that is above, an obtuse angle that is above 90 degrees to each other? So this is N, and this is east, and then south and west, and it's making an angle, let's say 120 degrees to each other. Or now I'm asked to find their resultant. R. Now to find their resultant R, remember it is not 90 degrees to each other. Remember they are not moving in the same direction. Also remember that it's not moving in the opposite direction. So I will no longer use the Pythagorean's theory. I will no longer use the addition theorem. I will use what I call the cosine rule. That is also what we our application for mathematics. Cosine rule. Let's say R squared now becomes A squared plus B squared plus 2AB cos theta. A squared plus B squared plus 2AB cos theta. Now let's still continue. We say this one is still 4 Newton. The other one is 3 Newton. Remember, they are no longer at right angle triangle to each other. It's now above 90 degrees. It's 120 degrees. We're given it 100, from here to here now becomes 120 degrees. 120 degrees is not up to 180 but above 90 degrees. So I use the cosine rule. Cosine rule. R square is equals to a square plus b square plus 2ab cos theta. So r square becomes 4 square plus 3 square plus 2 times 3 times 4 cos 120 degrees. 4 square is a square, b square is 3 plus 2ab, 2 times a is 4, b is 3 plus cos theta, which is 120 degrees. So we continue. R square is equals to, let's say, 16 plus 9 plus 2 times 3, which is 2 times 3, 6. 6 times 4 is 24. So 24 cos 120 degrees. 24 cos 120 degrees. What is cos 120? What is cos 120? R square. This is 25 plus 24. Now r square becomes 25 because 16 plus 9 is 25 plus 24 cos 120, and cos 120 is 0 minus 0.5 minus 0.5, and so I have r square. Okay, r square becomes 25 plus 24 times 0.5 minus 0.5. R square is equals to, okay, now r square becomes 25 plus 24 times 0.5, so minus 0.5. So we have 24 times minus 0.5. I'll be having minus 12. Minus 12. Minus 12. So r square now becomes 25 minus 12 becomes 13. So r now becomes the square root of 13. R square becomes the square root of 13. The sign will definitely change. Minus 0.5 times 24 is minus 12. Minus 12 plus, the sign will change. Plus minus is minus. So I have 25 minus 12, I will have 13. Remember, I am not looking for r square, but r. So r will become the square root of 13. The square root of 13 becomes 3.60, blah, blah, blah. So approximately 3.6 Newton. So now we are in order, and the resultant is now 3.6 Newton. 3.6 Newton. We are not using the Pythagoras theorem. We are not subtracting. We are not adding, because they are not in the same direction. They are above. It's got an obtuse angle that is slightly higher than 90 degrees. And so by solving the resultant of such vectors, I will use the cosine rule, which is r square plus a square plus b square plus 2ab cos theta. Remember, it has also sustained an angle. So I don't just leave it at, just like when we have 90 degrees. We had 90 degrees to each other, the resultant. Knowing that it's 90 degrees, yes, but it's also made an angle, and that angle I was looking for, I have to use tan theta is equals to opposite all over adjacent. But in this case, it has also sustained an angle, which I will no longer use the tan, I will use the sine rule. Sine rule. But before then, let me go through this thing again so it becomes clearer to us. I say if you have vectors, the same two vectors, but their angle are not 90 degrees, they are above 90 degrees, and we're giving at 120 degrees to each other. Let's say, since it's 120 degrees, it's above 90, which we have done before using Pythagoras. If it's 90 degrees to each other, or 45, that is less than, I have to use the once it's 90 degrees, I'll use the Pythagorean theorem. But if it's above 90 degrees, I'm using the cosine rule. If it is still less than, I'll still use the cosine rule. But as long as it is not 90 degrees, 90 degrees specifically, I will use the Pythagorean's theory. If it's less than 90 degrees, which is if it's up less than 90 degrees, it could be 60, it could be 45. If it's above, we are going to be using cosine rule. Either it's an obtuse or an acute angle, I will use the cosine rule, which is r square is equals to a square plus b square plus 2ab cos theta, when it is an acute or an obtuse angle. But when it is 90 degrees, I will use the Pythagorean's theory. And now, having known that, and I still have maintained that my A is 4 Newton, my B is 3 Newton, and then from the formula is a square, so 4 becomes square, plus 3 square, plus 2ab, 2 times 3 times 4, plus cos theta, which is given to us as 120 degrees. So r square is equals to 4 square is 16, 3 square is 9, plus 2 times 3, 6, 6 times 3, 6 times 4 is 24, cos 120, and cos 120 is minus 0.5. So minus 0.5 times 24, and we're having minus 12. So 25 plus minus 12 is 24 minus 12. If I have, just as it is here now, 25 plus 24 times 0.5, which is a negative sign, 0.5 minus 0.5 times 24, I will have minus 12. So if I have 25 plus minus 12, it's the same as saying 25 minus 12, because plus minus is minus in mathematics. Plus plus is plus, minus plus is minus, plus minus is minus, minus minus is plus. These are some simple rules in mathematics. So since I have plus minus is a minus sign, so 25 minus 12, I have 13. And I am not dealing with the square root of r. Sorry, I'm not dealing with the square of r. I'm dealing with r as an entity. So r becomes the square root of 13, which is approximately 3.6 Newton. So having known that if, and I'm still, it has to sustain an angle, which I will use the sine rule, no longer the cosine rule. Sine rule, which is, okay, now, when I said, when we are looking for the resultant, we are using this cosine rule. But when we are now looking for the angle sustained, and we use the sine rule, which is sine A all over R, which is our resultant, is equal to sine theta for the angle I'm looking for over A, which is our 4 Newton. So I have sine A, sine A is 120. 120 sine 120 all over R, which is 3.6, is equals to sine theta, angle I'm looking for, all over 4. A is 4. If I cross multiply, I have 3.6 sine theta is equals to sine 120 times 4. If I cross multiply, this multiplying this, I have this 120 times 4, then 3.6 times sine theta. Now 3.6 times theta, I am now looking for sine theta. So sine theta, what do? I divide both sides by 3.6. Divide both sides by 3.6. 3.6, so that this will go. I have sine theta is equals to sine 120 times 4 all over 3.6. And then remember 120 is minus 0.5 times 4 all over 3.6. Now, from here, I have sine theta is equals to minus 0.5 times 4 all over 3.6. And minus 0.5, I have minus 2 all over 3.6. And if I do that, I'm having sine theta becomes minus 0.55. Minus 0.55. Now, remember, I am not looking for sine theta, but the angle itself. Theta becomes sine inverse of minus 0.55. Theta becomes, I go through it again. Now I said if I am given an angle that is above 90 degrees. It could be an obtuse, it could be an acute angle, which is either above 90 degrees or below 90 degrees. And we use the cosine rule, not the Pythagorean theorem. Now, we have done using the Pythagorean theorem, and we have done using also the cosine rule. And then our resultant, but when it's being sustained, when the angle is above 90 or less than 90, the angle sustained will normally use the sine rule. But if it's 90 degrees, the angle sustained, you are using the tan theta, which is opposite over adjacent. But when it's above 90 and also above or below 90, the angle sustained, you are using the sine rule. The sine rule, which is sine A all over R is equals to sine theta all over A. I am looking for the sine theta, the angle sustained, and I'm giving sine A, which is 120 degrees. My resultant is what, after the cosine rule, what did I get as my resultant? Becomes R. And then, if you input it into this equation, now it becomes sine A, which is 120, is equals to 3.6, which is our R, which is equals to sine theta, what we are looking for, over A, and A is 4, one of the angle facing the angle, one of the force facing the angle. And so we have sine, if I cross multiply, I have 3.6 times sine theta is equals to sine 120 times 4. To get my sine theta, I will divide both sides by 3.6 so that it can cancel. If I cancel this, I have sine theta. Sine theta becomes sine 120 times 4 over 3.2. And 120 is minus 0.5. Minus 0.5 times 4, I have minus 2 all over 3.6. We have sine theta is equals to minus 0.5 times 4 because 120 is minus 0.5 divided by 3.6, which is our resultant. And when we do that, we have a minus 0.55. Then the theta, the sine inverse of this, I'm having minus 0.55. Sine inverse of it, I have a minus 33.36 degrees. And so the angle sustained, remember, we are dealing with angles, two vectors that are not in a right angle triangle to each other. It could be an obtuse angle, it could be an acute angle. For this today, we did about angle that is 120 degrees, which is above 90 degrees. In some other cases, it could still be the angle given to you is 60 degrees or 60 degrees or 70 degrees, that is less than 90 degrees, but it's not still 90 degrees. You are still going to use the pattern, are you still using the cosine rule? That is cosine rule, which is let's say a square c square is equals to a square plus b square. C square is equals to a square plus b square plus 2ab cos theta. This one becomes the cosine rule to get your resultant in the angle that is above 90 degrees or less than. If it's an acute or an obtuse angle, I use the cosine rule. And having done that, using to get your resultant, it must sustain at an angle. The angle sustained at that point, you are using the sine rule, not the tan theta. Remember, if it was 90 degrees, I'll use the Pythagorean theory to get the resultant, and I'll use the tan theta, which is opposite over adjacent, to get the angle. But when it's an obtuse or an acute angle, I will not use that anymore. I will use the cosine rule to get the resultant, and I'll use the sine rule to get their angle. The angle sustained here is sine L over B over R is equal to sine theta over A. The R is your resultant, which you got from the cosine rule. The sine A is given to us as 120, and I'm looking for sine theta. So, and A is 4 degrees from our question. So if you cross and multiply, you'll be having sine theta is equals to 120 times 4 over 3.6. So if I cross multiply this, multiply this multiply this. 4 times sine 120 is equals to 3.6 sine theta. That's what we did here. And to get sine theta, I will have to divide both sides by 3.6. If I divide both sides, this and this will go, leaving sine theta, making sine theta the subject of formula. If you are making the subject of formula, which means you must divide both sides by 3.6. So sine theta becomes 120 times 4 all over 3.6. And 120 is minus 5 times 4 divided by 3.6. If you go down, these times this I have minus 2 divided by 3.6, I have minus 0.5. I am not looking for sine theta, I'm looking for theta. So theta, because the sine inverse of minus 0.55, which is minus 33.36 degrees, that is the angle sustained. Right before we go, I have to go through what we have done today once again to make it clearer. If you are joining us now, okay, do well to pay proper attention. We started by talking about what is a vector quantity and why is it different from a scalar quantity. And we said scalar quantities are quantities that has magnitude, no direction. They have magnitude, no direction. They have magnitude as well as size, no direction. Example, we said speed, we said mass, we said temperature, we said work, energy, power. Those are examples of a scalar quantity. But a vector quantity is a quantity that has both magnitude and direction. Example, we have velocity, you have acceleration, you have electric field, and then you have momentum, and there are so many. And remember, I gave a very good example. I said, if, for instance, I asked a student, leave the classroom, walk 20 meters, and there is a bag of gold, diamond waiting for you out there. And then the question looks vague to the child because, am I moving 20 centimeters upward? As long as I'm leaving the class, and do I have to climb to the top of the roof? Is it 20 meters downward? Do I have to dig through the ground? Or is it to the door or to the window? The question is vague. But if I tell the child, as a student, leave the classroom, move 20 centimeters from the door or from the blackboard, using the blackboard as your center of reference, and then move 20 centimeters northward at 40 degrees or 45 degrees south. And so I am not specified. The child knows where to go to search for the goal because the direction is specified. And so vector quantities are quantities that has magnitude and as well as direction. And we said vectors, calculating the vectors of a scalar is practically negligible. It's of no use because it's just a single vector. Move northward, okay, move 50 meters. To where? There is nothing to calculate there. But if I'm asking you, if I have two vectors and I say, okay, they are both moving in the same direction, what is their resultant? Then calculation can now come in, and that is a vector quantities. So vector quantities, if they are in the same direction, what do? I will add their resultant because they are moving in the same direction. And I gave example on the board. And also said if they are moving in the opposite direction, so we say one is going south, another one is going north. So what is our resultant? I have to subtract because they are moving in the opposite direction. But if they are moving at a right angle triangle to each other, so one is going north, the other one is going east, or one is going south, the other one is going west, at that particular point they are making at an angle which is 90 degrees. Either they use the word 90 degrees or use the word right angle triangle to each other. Automatically you know it is 90 degrees. So how do I calculate the resultant? I will use the Pythagorean's theorem, which is let me just put it again for clarity's sake. I have if they're in the same direction, I add 1. If they're in opposite direction, I subtract. If they are right angle triangle to each other, which is 3, if they are moving at a right angle to each other, let's say one is north and the other one is east, or one is south and the other one is west, I will use the Pythagorean's theorem, which is a squared is equals to b squared plus c squared. But if and at that point that right angles to each other, they must sustain at an angle. The angle there is tan theta. That's 4. Tan theta is equals to opposite over adjacent. Opposite over adjacent, because if it's 90 degrees to each other, it must make an angle. The angle here is tan theta. That is this. But the resultant is r, which is this. I'll use the Pythagorean's theorem. Now 5. If the angle is above 90 degrees or less than 90 degrees, it will either be an acute or an obtuse angle, I will no longer use this or use this. I will use the cosine rule, which is, let's say c square is equals to a square plus b square plus 2ab cos theta. And then c is that angle, because it's above 90 or less than 90, it has to still sustain at an angle. The angle must be calculated. So I will use the sine rule. The sine rule, which is, will be sine A all over R is equals to sine theta all over A. Depending on the alphabet you are looking for, you can decide to say sine X all over sine R, or for the most important thing that the angle given to you and the resultant from what you are getting for the cosine rule can be calculated using the sine rule. Using the sine rule. So having known this, now as we proceed in this class, and then you begin to see when you have vectors that are both 3 magnitude, you have 4, like now we're dealing with vectors of 2 magnitude, 1 2 1 2, one is going east, whatever one is going west. Okay, 4 Newton, 3 Newton, 5 Newton, 6 Newton, say 2 vectors. But what if they are above? They are above, let's say, vectors of so you have vector 1, you have 2, you have 3, you have 4. What do? I have to still calculate the resultant, make it to be 2 vectors, put them into Pythagorean theory to solve. If there are 4 more than, I have F1, I have F2, I have F, depending on, let's say, Newton 1, let's say Newton 2, Newton 3, and Newton 4. The resultant can also be calculated. But as we proceed more, in let's say when we get to that level, it becomes clear to us. So that's, in that case, we have to resolve them. If there are 6 vectors, resolve them into 2 vectors. If they have 4, resolve them into 2 vectors. If there are 3, resolve them into 2 vectors and still apply your Pythagorean theory. So if you have 2 vectors, what we did today is 2 vectors are either an acute angle or an obtuse angle or 90 degrees. We use either of these Pythagorean theory, cosine rule or sine rule. But when the vectors, when the forces are more than 1, not more than 3 or more than 2, and then we have to still learn how to resolve them into 2 vectors and still apply our Pythagorean theory. But as we go further into this course, we'll make that clear to us. And so I believe for today we have done justice to scalar and vector quantities.